Tropical. Tropical.
I don't know what you're saying.
Like, what's the difference between tropical and tropic?
This is yours.
Yes, you can start.
I don't know how to explain it.
Organisms that make their own food are called autotrophic.
Medina, that's one.
Right. Auto makes self and trophic makes feeder. Therefore, an autotrophic is a self-feeder.
All right, pause there. So what should we be circling? What should we be circling? Omar?
Autotrophics.
Autotrophs. There's no IC. Troughs. Autotrophs. So let's circle autotrophs.
And then
Everybody should be circling autotrophs because that's our term to define. And who thinks they saw the definition that we should be underlining? What should we be underlining, Angel?
organisms that make their own food.
Yeah, organisms that make their own food are called autotrophs. So underline that right there. Organisms that make their own food are called autotrophs. Organisms that make their own food are called autotrophs. If you also want to underline auto means self and troph means feeder, that is also good to know. However, that's not necessarily the definition. But if you want to include it as your definition, that is perfectly fine. Great job, Ms. Diallo. Great job, guys. Okay, so we're going to continue on. Francisco.
Sure.
Any yours?
They use the food they make as an energy source to carry out their life functions. Examples are plants that make their own food by transforming the radiant energy from the sun to chemical energy through the process of photosynthesis. Autotrophs are also known as producers. Some bacteria are autotrophs. They use chemicals in their environment to make their own food. Some protists, such as euglena, can make their own food. They contain a structure called a chloroplast, as they use sunlight for photosynthesis.
Great job, Francisco. Alright, so what is an example of an autotroph that they gave us? What's one example? Yeah? Plants, very good. So put example next to plant. There are also other examples. We can find another example that they had for us. Darius? Photosynthesis? That doesn't sound like an example of an autotroph. Anthony, you want to help him out? Euglena, that's one, right? And what's another one? So we've got plants and we've got euglena. What's the last one, Ms. Kiara? Bacteria. Some bacteria, right? So you should have three different examples that you can use. Bacteria, plants, and euglena. What's one, Omar? Huh? Bacteria. Darius, what's another one?
Euglena.
The E is always going to be silent on words like that. So you bacteria, euglena, right? The E is silent. Euglena. Makai, what's the other? Sorry. What's the other one? Where is the plant? Yes. Good. Yes. Oh, very good. Yeah, moving on to heterotrophs. Organisms that cannot make their own food are called heterotrophs. Right, Alicia, go ahead and pick up.
Where are we?
Organisms that cannot.
No,
Savannah,
I want to read
pick
that.
up.
I really want to read that.
Savannah, go ahead and pick up.
Okay. Organisms that cannot make their own food are called heterotrophs. Heterotrophs?
Yep.
Okay. Heterotrophs. Hetero means other. Means other, and tro means better. A heterotroph must feed off of others. They get their energy from eating autotrophs plants or eating other heterotrophs.
All right, let's pause there. So we got some cool information. Do you think they understand which term we should be circling? Where should we be circling? What should we be circling? Yes. Jenna.
Heterotrophs.
Heterotrophs? Okay, Anthony, what do you think we should be circling? Tiana, what do you think we should be circling? Consumers? Omar, what do you think we should be circling?
I think we should start,
Heterotrophs? Okay. Ida, what do you think we should circle?
Autotrophs.
Huh? Autotrophs. You're the
Yeah, I
only
think
one.
that's another one that we should circle.
There's no autotroph in that paragraph.
Yes, there is. Yes, there is. They get their energy from eating autotroph plants.
Oh,
or
okay.
eating
So
other.
that's where you're pointing to? Yep. Okay. Alicia, what do you think?
Where it says like the definitions, like hetero means other and troph means feeder.
So that's the term that we're going to be circling, is the definition?
Yeah.
The term we're going to circle
Oh,
is the definition.
definition.
Huh?
That's the definition.
So what term should we circle, Darius?
heterotroph.
Huh?
Heterotroph?
Heterotroph. Alright, so we're going to circle heterotrophs, because that's what our paragraph's about, right? So go ahead and circle heterotroph on your page, so that everyone is clear that this paragraph is about heterotrophs. So what's our definition that they gave us for heterotroph, Omar?
The definition that they gave for heterotroph is organism that cannot make their own food, and they also goes on the line of a heterotroph must feed off others. So basically, the first and second lines.
Okay. Thumbs up if you agree with Omar. Thumbs down if you disagree. Thumbs up, thumbs up, thumbs up, thumbs up. You got some people who don't have any thumbs. Oh, you got some thumbs. How you got thumbs? Show them thumbs. Great job, dude. Awesome, awesome, awesome. What happened to your thumb? Okay, cool. Great, we got all thumbs. Cool. Yeah, I agree. So, those first two sentences, you can go ahead and underline those two sentences. Organisms that cannot make their own food are called heterotrophs. A heterotroph must feed off of others. They gave us some examples. We're going to start off at examples and read. Faith, go ahead and read for us. Examples are
Animals, mushrooms, and mold.
Yep, speak up just a little bit.
Euglena are able to consume food when light is not present. Heterotrophs are also known as consumers. Heterotrophs transfer the chemical energy from food into other forms of energy for food.
Very good. Thank you very much, Faith. All right, so what's those examples? Some things they can find one, write an example. What's one example? Darius, what's one?
Animals.
Animals, that's one. Angel, what's another? Huh?
Mushroom. No,
That's
That's
not
what a heterotroph is.
Oh, no.
What's an example of a heterotroph? Faith. Mushroom, what's another one?
Mushroom.
Molds, there you go. So we got it. So we got animals, we got mushrooms, we got molds. There's one more example if you want to put it. Alicia, what do you got?
Why does it say back to?
Does it say bacteria?
No.
No.
Does it say bacteria?
No.
Savannah. You clean up. There you go, Savannah. You're a roll today. Fireball. All right. Let's go ahead and turn the page. We've got our examples. We've got our terms. So our second way of being able to identify an organism and what kingdom or domain it is in is based off of the number of cells. So we're going to start off with the first type, which is unicellular. Ms. Beato, go and read for us.
All organisms are composed of cells. Unicellular organisms are single called one. Uni equals one. This one cell carries out all of the functions necessary to keep the organism alive. Bacteria are examples of unicellular organisms. Many protists are unicellular as well.
Thank you very much, Ms. Beato. So, what is our term that we should be circling, Francisco?
Unicellular.
Unicellular. Does everybody agree? Thumbs up if you agree. Thumbs down if you disagree. I don't see any disagree. No disagree. No disagree. I disagree.
Oh my God.
No, I'm kidding. I don't really disagree. All right, so let's look at our definition then. Since we already got our term, what's our definition for unicellular, Margaret?
Organisms are, unicellular organisms are single celled.
Unicellular organisms are single celled, right? Uni means one. You could also put that if that helps you, so you can underline that whole thing. Organisms are single celled. Uni is one. Good job, dude. You got it, William? got some examples. So what's an example of a unicellular organism, Madison?
Oh wait, bacteria.
Bacteria. What's another one? There's one more. Kaina. Protist. Yeah, good job. So we've got our two examples. So make sure you got examples by both of those. You got bacteria as one, and you got protist as the other. You should have example on those two words. So, give me a couple seconds. Multicellular is our next term. Omar, go ahead and record.
Multicellular organisms. All organisms are composed of cells. Multicellular organisms are made of many cells. Multi equals many. All of the different cells are specialized to do certain tasks. Humans have skin cells, brain cells, and blood cells, just to name a few. Animals and plants are an example of multicellular organisms. Most fungi are multicellular, and a few protists are as well.
Great job, Omar. So, what's the term that we should be circling? Who hasn't been heard today? Ida.
Multicellular.
Multicellular. Anybody disagree?
No. No.
We gotta disagree. Madison, what do you, or Medina, what do you think?
I said no.
What? You have your hand up. Okay.
No. I raised my
Alright,
hand
so
and
if
I
nobody
said
disagrees, then what is our definition? What's our definition? What should we be underlining today, Angel?
no.
Just grab some water. Go to that. Say that one more time, Angel. Sorry, I didn't hear you. Multicellular organisms are made of many cells? Huh.
No.
Medina, what do you think?
I think it's organisms that are made of many cells.
Okay. Bates, what do you think? Oh, you go to the bathroom? You want to answer first?
Can you repeat?
What do you think the definition is for multicellular?
If you want me to read it from here, put it in my own words. It says multicellular organisms are made of many cells.
Is that what you think it is?
Yes.
Okay. Darius, last one.
I mean, this could also be like, to them, like, all organisms are composed of cells.
I wouldn't say that's the definition. I'm going to go with what we said first 3 times. So, multicellular means that the organism is made of many cells. Because it also says that multi equals many, right? So multicellular means an organism made of many cells. Okay? Multicellular. So I think we can underline both of those things. Organism made of many cells, and multi meaning many. What's an example that they gave of a multicellular organism, Kaina? Animals, yes. Margaret, what's another one? Plants. And what's the last one that they gave, Jaylene?
Humans.
What?
Humans. Oh, you're right. Oh, she's right. Humans. Yeah. Humans are multicellular. Let's say it's Diana. Or John. What's another one? Fungi is the most. Now the tricky thing with fungi is that they can be unicellular, but they can also be multicellular, so it kind of depends. And then there's another one that could be multi-things as well.
Me?
Yeah.
Okay. Few protists.
And protists, right. So protists again can be either uni or multi. Alright, let's go ahead and turn the page to number 3. The third way you can categorize an organism is based off the presence of a nucleus, one being prokaryotic, the other being eukaryotic. We're going to read prokaryotic right now. We're going to read for it.
Made of cells which carry the functions necessary to sustain life. A cell is the basic unit of structure and functions in an organism. Just as our bodies are made up of many structures or parts that work together, cells have many structures or parts that do the same. Structure is the parts it's made of and how it's put together. The function is the job each structure performs. Organisms called prokaryotic do not have prokaryotes do not have organized structure called the nucleus that contains genetic material and controls the cell. Genetic material is just floats around inside the cell. Pro equals 4, eukaryotes equals nucleus. No nucleus.
Anthony, read the last line.
You can remember that prokaryotes with no bacteria are examples of prokaryotes.
Thank you very much, Anthony. So, what is the thing that we're trying to define? Who's got an answer for us? What should we be circling, Miss Beato?
We should be circling prokaryotes.
Prokaryotes. Yeah, we should be circling prokaryotes. Make sure everyone has circled prokaryotes. What should we underline? Blair.
Do not have.
My leg.
Alicia went out, bro.
Yeah.
We got
It says prokaryotics do not have an organized.
prokaryotes. So there's a difference between prokaryotic and prokaryote. Make sure you're reading the right one.
Prokaryotes do not have an organized structure called a nucleus that contains genetic material and controls the cell.
Everybody see that line?
Mm-hmm.
Do we see that line?
Mm-hmm.
Do we agree that's the definition?
Mm-hmm.
Hilarious, what's the definition? Prokaryotes.
Prokaryotes do not have an organized structure called a nucleus that contains genetic material and controls the cell.
Great job, Larry. So let's go ahead and underline that as our definition for prokaryotes. Prokaryotes do not have an organized structure called a nucleus. You don't even have to put the rest of that as long as you know that it's a nucleus. And if you want to put pro equals to 4, and karyote equals nucleus, no nucleus, you've got your definition. What's a cool rhyme that you can use to save yourself some time and try to distinguish between the two? Pro no. Yeah, good decision. And what's the example that they gave us of a prokaryote, Savannah?
Make the example of
Prokaryotic cell.
I just had bacteria.
Bacteria, awesome. And lastly, we're on to eukaryotic cell. All organisms are made of,
All organisms are made of cells which carry on the function necessary to sustain life. A cell is the basic unit of structure and function in an organism. Just as our bodies are made up of many structured parts that work together, cells have many structured parts that do the same. The structured part is made of and how it's put together. The function is the job each structure performs. Organisms called eukaryotes do have an organized structure called a nucleus that contains genetic material controls to the cell. EU equals true and karyote equals nucleus, true nucleus. You can remember that EU rhymes with true and new animals, plants, fungi, and viruses are examples of eukaryotes.
Very good job, sir. Ida, what is the term that we should be circling? Eukaryotes, very good, Ida. Anthony, what is the definition that we should be underlining?
Eukaryotes do have an organized structure called a nucleus that contains genetic material and controls the cell.
Great job, Anthony. So, eukaryotes do have an organized structure called a nucleus that contains genetic information and controls the cell. What is the example of a eukaryote that they gave us, Madison?
Can I add on to the definition, please?
Sure.
I know this is probably not related to anything, but there was another definition in here that it's not for eukaryotes, but I think it's for itself, and it says a cell is the basic unit of the structure and function.
Yeah, so that is true. I wouldn't necessarily put that in eukaryote, but if you want to make that as a note for yourself, that's definitely cool. Omar, what are you doing? All right, we're on our last one before we get on to the activity. So let's go ahead and move on to the last way that an organism can be classified. I'm actually going to read through this one so we can get through it really quickly, so we can get to the next part so you guys can get into your group work. We're still going to break it down into the term and definition, so make sure you're reading on your page and tracking what I'm reading so that you know what's going on. You should not put your head down. You should be reading your page. So, how an organism reproduces, the first way is asexual reproduction. Genetic material from parents to offspring, or babies, during reproduction. Asexual reproduction, Jonathan, you should be reading your page, is a process that only involves one parent, not two. A equals not sexual. The offspring will be identical to their parent, so basically it's a clone. The genes of the offspring are exactly like the parent's genes. Bacteria are examples of organisms that reproduce asexually. Bacteria will divide in half to form two cells identical to the original cell. This is called fission. Some plants, fungi, and protista can reproduce asexually. In rare instances, there are animals, such as the sea anemone, that can reproduce asexually. So what is the term that we're trying to define, Faith? We've been doing it for 20 minutes.
I mean, it's not okay.
I know.
Oh, my turn.
Asexual.
Asexual, right. What's the definition that we need to find? Yeah. Definition, yeah. Good. A process that involves one parent, not two. And finally, what are some examples? Darius. Bacteria. What's another example, Medina?
Another example is plants,
Ramid.
fungi.
Margaret. Great. Are there any other ones, Kaina?
It says sea and
Sea anemone. So animals like sea anemone. Cool. That is also true. Make sure you got examples next to all those. Let's go ahead to sexual reproduction. Sexual reproduction, genetic material is passed from parents to offspring or babies during reproduction. In sexual reproduction, offspring result from the combination of genetic material from parents A, male, and A, female. They get half of the genetic material from each parent. The sperm from the male contains half of the genetic material, and the egg from the female contains the other half. Because offspring inherit a combination of genetic material from both parents, they are not exactly like either parent. Animals and most plants reproduce sexually. Some fungi and protists can reproduce sexually. A paramecium is an example of an organism that can reproduce both sexually and asexually. And you can kind of see the pictures of those things at the bottom. So what's the term that we're trying to define, Alicia?
It's sexual reproduction. The definition is offspring result from the combination of genetic material from two parents, a male and a female. Sorry, like next sentence or no?
You read more than you needed to read. You just have to read the term, right?
Yeah.
Not following directions. Yeah, we got our term, we got our definition. Very good. And what's an example, Darius?
Fungi and fungi.
What's another or Kaina? What's another example?
plants.
Plants. And Francisco, what's another example?
Some fungi and produce.
Some fungi and produce. Great job. Go ahead and track front. We're gonna work on our packet. The packet should look like this. Go ahead and pull that packet out and this one. Should look like this once you got it. Just hold it up real quickly so I know that you have it out. Great. Awesome.
Oh, high five.
Great. All right, coming down. Good job. So when you're doing this, you're basically using the notes that you just gained in order to fill out this chart, okay? Savannah and Medina. So we're gonna start off with one. I'm gonna do one by myself. I want you guys to also fill in your charts, just like I do it. and then you guys are gonna work as your table partner to fill out the rest of it, okay? So for number one, I've got one right at the top, I can see it. The title says how organisms get energy. That's my first characteristic of classification. So on number one, all right, how an organism gets energy. And now we've got two different points. It says makes food or consumes food. So I'm gonna write the term what it fits in. So which one would fit under makes food? So who thinks they know? Raise their hand. Adina, what do you think?
Autotroph.
Autotroph? Darius, what do you think? We only got two options. What do you think makes food?
Oh, autotroph.
Autotroph? Diana, what do you think? What do you think? You think it's autotroph? Hector, what do you think? Autotroph. Okay, so mixed food is autotroph. And so what does that make for consumed food, Savannah?
Can you repeat that?
Which one is consumed food? Heterotroph. Good job. And now we've got some room for examples that we've already taken the great time to list out for ourselves. So Ms. Beata, what's an example of an autotroph?
An example of an autotroph is some bacteria.
Bacteria, okay. What's another example, Larry? Okay, come back to you. Omar, let's find one. Plants. What's another one, Angel?
What does that say?
Euglena?
Bacteria plants.
How do you spell euglena?
It's on the page for you. Well, Laris, which one for a heterotroph? What's an example for a heterotroph? Or number one.
I can't find it.
Heterotroph. What's an example?
It's right there at the corner.
I don't see it.
What's another example for a heterotroph dairies?
Mushroom.
Mushroom.
I heard it. Oh.
And what's one more example, Marty? Mold. Good. Alright, so everyone see what to do?
Yeah,
Pretty simple, right?
Yeah.
Alright, go ahead and work with your table partner. Complete 2, 3, and 4. And put 6 minutes on the clock. Go. Yeah, what you gotta do your table partner. If you don't have a table partner, you don't have one.
What time we get out?
So the one that has one is
How do you say it? Francisco.
Okay, so
heat and
I know.
So when we okay. Oh wait. This is critical. If I put the question, how an organism get number
Organism.
how an organism gets a number of cells? That's a good question.
No. It's just the number of cells. How do they classify? By number of cells.
That's easy. Oh, you can put this over here. No, it's
Oh, bacteria.
Okay. Nobody said anything.
1 U9. Example for bacteria.
It came out like only bacteria. 3 is present.
Animal and plant.
How you gonna put it right here?
Yeah.
Patriots about
But did it say examples? Did you say what is?
Okay.
Amelia. Patriots.
Presents. Presents.
Commons.
And then you that
First one looks like one pyramid. It's like
like this.
Eukaryotic cells.
Example.
cyan.
Bacteria. Like bacteria.
You know that already.
I just don't like
Animals, plants, fungi, and protists.
Drag me in 5, 4, 3, 2, 1. Thank you, Omar. Thank you, Taina. Thank you, Miss Beata. Thank you, Margaret. Waiting on a few people in column 3 to track. Dina, Savannah. Track. When you guys finish, if you finish that early, you guys can move on to the second page in your packet. Don't go over to the last one yet. Just go on to the second page. We'll talk about the last one in a minute. But you got 2 minutes left. Go back to it.
Okay. Next one.
And then my mom moved here and grandmother and she asked me if I can see like you
You know when I came late, right? I went to the bathroom because I see Ramada move back in the front. I was like, I know she's inside putting mascara on. So,
Yeah, boyfriend now.
Second page says, how I met my
No, Madison, stop. You're making me laugh.
And then she's like, no,
okay,
it's
one.
just,
Hey, she put mascara on. So this is where I was doing.
she's like, how do you make your own food? I was like,
Oh, what?
I am on my kitchen.
So this was the order I went to. I think I put some on food. Is it too
Put the thing back in.
until she
Put the cheese, the mac,
Not like that.
a little bit, and we're good.
Not like
She's
that.
throwing her sister,
Like
Yes.
Is it? No, I thought it was ass. Not like. Oh, not like that. But like AS, like ass, like ass.
That's what I said. I made
Wait, so you're putting this here. Then you're putting this there.
You have
I made my food.
That's not.
On the stove.
That's
On the
what
stove. I made my food. Dang it.
This is really what happened.
If you
like, you know.
I want to make mac and cheese burgers like everybody else. So I think what do you want?
You know what I was that you probably would you try to talk to us?
Yeah, we had an argument.
Sorry, that's a good
Thank you, Faith, for being the person who realized the buzzer was going. You should be tracking. Thank you, Margaret, for realizing the same. Thank you, Darius, for doing it. Thank you, Ida. Thank you, Anthony. Thank you, Omar, and where should we all? Alright, so at this time we are moving on to our independent time. There are two pieces that I want you guys to work on. The first piece is that piece that you started working on together. That's based off of today's lesson. I lost some eyes. You should be tracking me still. Thank you very much, Medina.
Sorry, there's something happening with my
Thank you very much. So that first page is based off of what you should be doing today. Rodrigo, grab a pencil. The second page is based off of the past lessons, okay? It's based off domains and kingdoms, so you can look back at your notes and do that one. Do not do the last page. Make sure you bring back this packet for tomorrow, and we'll work on that last page tomorrow. Everybody clear on that?
Yes.
Yes.
All right, so independently work on those two pages. Go. No, your homework. Oh yeah, sorry, I forgot to mention that. Track me one more time. 5, 4, 3. What? Omar, is she tracking? Medina, that's 1. I'm not gonna keep it. Thank you very much. Alright, so these two pages that you should be working on, if you come in tomorrow with these complete, 100% correct, they are worth extra points for your quiz on Thursday.
Oh, thank God.
If you have anything wrong, you lose those points. Okay? So it's a perfect opportunity to get everything right, put your effort in, make sure everything is good, and then you'll get those extra points tomorrow when we go over it. Alright, so try your best. Go back to it. Yes, Omar.
For this, we're supposed to put the thing that it is, like
Yes.
plants or.
Well, the first one should be based off the category. The second one should be like plant A.
So the
Yeah, the
kingdoms.
second page.
So the kingdoms.
Yes, the second one should be kingdoms and domains.
One cell. Who am I?
What, if you're asking tomorrow?
Or what am
Oh, Thursday?
Shouldn't it be what am I?
You get it when you come back, yes. It's independent. Voices, please. Thank you. Yeah, so the first page is, yeah, you're
Mr. Marshall, why don't you say that E on your periodic? When it
You
says
do. It's just the way you say it. It's A-U, A-U, A-U. So the way you say it, it's so quick that it's U. A-U-K.
Okay, so for this one, like I just say I made my own chord, so basically it's just I just put all my topics. So I would just put this